Have you ever wondered if the human lifespan could be extended beyond its current limits? This question has sparked the imaginations of scientists, philosophers, and dreamers alike for centuries. And today, we stand at the precipice of a new era, where this once fanciful notion is inching ever closer to reality. The quest for longevity, the extension of our natural lifespan, is no longer a mere thought experiment. It has become a tangible field of research, with scientists across the globe delving into the mysteries of our biological clocks. From the cellular level to the complex interplay of our systems, we're beginning to understand the intricate symphony of life and aging. At the heart of this exploration lies the concept of advanced rejuvenation biotechnologies. These are the cutting-edge tools and techniques aimed at not just adding years to life, but more importantly, adding life to years. The focus is on enhancing the quality of life, ensuring that our extended years are not merely a prolonged experience of frailty and disease, but an opportunity for continued growth and vitality. But how do we navigate this uncharted territory? How do we quantify life and aging? And how can we possibly extend something we're only just beginning to understand? Enter the McGinty Equation. This mathematical construct serves as a compass in our journey, a guide to understanding the mechanics of life and aging. The McGinty Equation, in its simplest form, is a solution of the free quantum field theory and mechanical systems. It incorporates the effects of gravity on the quantum field, characterized by a parameter g. It also introduces a fractal potential term, which describes a self-similar fractal structure, a pattern that repeats at every scale. This fractal correction term is derived using integral calculus, Laplace transform, and the convolution theorem. To grasp the potential of extending human life, we first need to understand the McGinty Equation. Join us as we delve deeper into this mathematical marvel and explore what it could mean for the future of human longevity. The McGinty Equation may sound complex, but let's break it down. It's a beautiful piece of scientific work that marries quantum field theory and the fractal structure of the universe. In essence, the McGinty Equation is written as P's xt equals P's qft xt plus P's fractal xtdm kqs. Now that might look like a mouthful, but each symbol has a clear meaning. First we have P's xt, which is our total quantum state at a point x and time t. This is what we're trying to figure out. Next up is P's qft xt. The qft here stands for quantum field theory, a cornerstone of modern physics that describes how particles like electrons and photons behave. So, PSQFT represents the solution of quantum field theory at a point x, at a time t. This part of the equation tells us what's happening in the quantum world. Now let's dive into the second part of the equation, P's fractal xtdmqs. This is where things get really interesting. The term fractal refers to patterns that repeat at every scale. Think of the intricate designs on a snowflake or the branching of trees. Here, P's fractal xtdmqs represents the fractal structure of the universe, with d, m, q, and s being parameters that describe this structure. This part of the equation considers the universe's fundamental, self-repeating patterns. In short, the McGinty Equation is a holistic model that seeks to understand the universe by combining the microcosm of quantum physics with the macrocosm of fractal structures. It's like a cosmic dance, where quantum particles whirl and twirl amidst the grand pattern of the universe. So there you have it, a simplified breakdown of the McGinty Equation. It's a testament to the beauty and complexity of our universe, a blend of quantum mechanics and fractal geometry. With this understanding, we can move on to the modifications of the McGinty Equation. Modifications to the McGinty Equation offer even more insight into the mysteries of longevity. Let's take a deep dive into the modified McGinty Equation. The equation is denoted as P's xt equals P's qft t xt plus P's fractal xtdmqs plus P's gravity xtg. The added term here, P's gravity xtg, is the game changer. It represents the perturbative effects of gravity on the quantum field. Now you may wonder, why gravity? Well, gravity is the very fabric of our universe. It's the force that keeps our feet on the ground, our planets in orbit, and even affects the passage of time itself. so it only makes sense to include it in our quest to understand longevity. The terms gravity, KTG, may seem complex, but let's break it down. The G in this term is a parameter that characterizes the strength of the gravitational force. By including this term, the modified McGinty equation takes into account how gravity might influence the processes that contribute to aging. But there's more. The modified McGinty equation also includes the fractal potential term VYYT, with a self-similar fractal structure. This structure is described by the constant parameters V0, L, and S. The fractal correction term can be derived using integral calculus, Laplace transform, and the convolution theorem. This shows the sophistication and depth of the equation. The modified McGinty equation isn't just a mathematical curiosity. It's a tool for probing the mysteries of aging, a lens through which we can explore the intricate dance of biological processes, quantum physics, and the fundamental forces of the universe. And there lies its true beauty. It's a marriage of the macro and the micro, of the immense force of gravity and the subtle quantum fields, all tied together in the quest to understand and ultimately extend human lifespan. So when we look at the modified McGinty equation, we're not just seeing a string of symbols and numbers. We're seeing a roadmap to uncharted territory, a guide to the unexplored frontier of longevity. This equation, combined with general relativity, may hold the key to unlocking extended human lifespan. So, what does all of this mean for the field of longevity? Let's recap. The McGinty equation, in its original and modified forms, represents a profound leap in our understanding of quantum field theory, and the potential implications of these equations for longevity are nothing short of revolutionary. The equation's ability to factor in the perturbative effects of gravity on the quantum field, along with their self-similar fractal structure, opens up exciting possibilities for future research into advanced rejuvenation biotechnologies. By applying these equations, we could potentially develop strategies to counteract the negative effects of aging at a molecular level, thereby improving the quality of life for our aging populations. Imagine a world where the secrets of extended human lifespan are unlocked by complex mathematical equations. It may sound like science fiction, but thanks to the McGinty equation, it's a future that's within our reach. As we continue to unravel the mysteries of the universe through equations like the McGinty equation, we step closer to the possibility of extending human life.